We're going to examine reverse engineering. Why do we use reverse engineering? And what are the steps? Now, if we look at forward engineering versus reverse engineering, our project was reverse engineering as we played with our wind up toy. Forward engineering is the process of moving from a high level extraction and local and logical designs to the physical implementation of a system. Reverse engineering is the process of taking something apart, analyzing its workings in detail, usually with the intention to construct a new device or program that does the same thing without actually copying anything from the original. Another time reverse engineering may be used is if you have lost the documentation, you've lost the prints, and this has happened in the past before we had drawing online. The actual prints may have been misplaced. Bless you. The prints may have been misplaced to build something. And the way they regenerated the way they redid the prints, they were regenerated because they took the object, whatever it was, apart, such as they were talking about during World War II, the airplanes that were taken apart, and then seeing what the technology is. Now, why reverse engineering? The original manufacturer of a product is no longer producing a product. That company is either out of business or they're no longer making it because it wasn't as profitable to them. The original design documentation has been lost or never existed. Some things back in the day were made as you were in the lab and you did not have an actual blueprint. So people made it from memory. We used to have model shops, and in those model shops, you could actually make things. And in the model shop, you may have tools like lathes. You could have the equivalent of you all's 3D printers now. Some bad features of a product need to be designed out. That's another reason for reverse engineering. Other reasons, you're exploring new avenues because you want to improve the product's performance or the features. You want to gain a competitive benchmarking method to understand what the competitor's doing, and you want to develop new products. Say you want to improve upon the Samsung phone versus the Galaxy versus the iPhone. You want to update obsolete materials or antiquated, outdated manufacturing processes with more current, less expensive technologies. You want to employ Lean Six Sigma, and that is going with less expensive technologies. You're saving money, you're saving time. Reverse engineering includes identifying the system's components and their interrelationships. So when you all had your actual toy that you were taking apart, you were looking at each component, and that's why I said make sure you save your screws, your springs, everything, because you were listing what was the job of that part. You're creating representations of the system in another form or a higher level of extraction. You're creating the physical representation of that system. Now, the steps of reverse engineering. Your prediction. What is the purpose of this product? What does this product do? How does it work? What market was it designed to appeal to? Now, when you say what market, the phones now, I'll pick on the phones. They're different colors. They used to be black or white. Now you can get a green one, pink one, whatever color you like. So, what appeals to you? List some of the design objectives for the product and list some of the constraints that may have influenced the design. Steps of reverse engineering. Observation. How do you think it works? When you look at something, you're getting in your mind what is going on, what is being done. How does it meet design objectives overall? Why is it designed the way it is? If you think of a camera that's used underwater, I'm sorry. If you think of a camera that's used underwater versus one that's used on land, that would have a different design because you're going to have to keep the water from flowing through the camera, ruining it. And especially salt water because it will rust the parts. Disassemble. How does it work? How is it made? How many parts do you have? How many moving parts do you have versus still parts? Did you all run into any surprises when you took apart your toy? Except I don't think anyone here had the train. The train was actually glued together. The steps of reverse engineering. Now, the steps that we're going to look at for reverse engineering. First, we want to analyze. You want to carefully examine and analyze. That was one of our words of the week. Carefully examine and analyze subsystems, such as your structure, your mechanical, and your electrical. We had 9 core technologies. Those are your subsystems. Develop annotated sketches that include measurements and notes on components, systems design, safety, and control. Your next step is test. The steps of the engineering process called tests. So first we had analyze. Now we're dealing with test. You want to carefully reassemble your product. You're going to operate the device and observe observations about its performance in terms of functionality, operational and ergonomic, and projected durability. Did anyone put their project back together, their wind-up toy, or they just played with it beforehand? Because someone in the other class did take theirs apart and put it back together. The next step of reverse engineering is your documentation. And your documentation includes your inferred design goals, your inferred constraints. Do you all remember what constraints are? Remember constraints? You don't have unlimited funds. Huh? You will have limited funds, but some of the things you may have limited space. Say you're coming up with a project and it needs to go into a certain space. You can't occupy the whole room. It may need to be in the space of a closet, say 2 feet by 3 feet. You may have 4 feet by 8 feet. but it's not the whole room, which is 10 by 12 or 30 by 40. Your design. What is the functionality of it? What's the form? You're looking at your geometric form. Remember the different images we looked at, the different views we looked at? What materials are you going to use? Are you going to use steel? Remember, stainless steel is expensive, it's lightweight, but that may be one of the constraints. Also, if you're sending a rocket ship up to space, it needs to weigh as less as possible for takeoff, yet be functional enough to save our astronauts. Schematic diagrams. They're showing you what goes into the part, where it's listed, where's your electrical outlets, where is your coding, what coding goes where. Your list, the list of materials. I thought someone said something. Your list, what are your materials? What's the components? What's making it up? What are your critical components? What's the flaws? Have you been successful before? And others. You want to identify any refinements that must enhance the product's usefulness. You want to look at upgrades and changes. I guess I teased the Apple because students in one class told me a couple of weeks ago that there's a new Apple phone coming out. I thought they came out in the fall. But an upgrade, a change, something that's different. I know we have operating software, whether you're on a cell phone or a PC or a laptop, your software is periodically updated. That's it. Questions?